Now, what is active power? It is also called true power or real power. It is defined as the average power taken by or consumed by the given circuit. What is active power? The average power taken by or consumed by the given circuit. This active power contribute to the useful work. See, we are giving supply to the simple lamp. So, lamp will glow and gives illumination to the surrounding. So this is what the useful work. We are giving supply to the motor. Motor is running. Motor is rotating and doing its useful work. So this is what due to active power. It is consuming that active power. So the power which will be converted into the useful work, this power is called as the active power. It is denoted by P, capital P, and measured in watts. Often you will see when you purchase any equipment, electrical appliances, then the power is mentioned in terms of watt or kilowatt if it is a high rating, right? So this is what the active power. So it is actually consuming to do some useful work. This formula is given by P is equal to VI cos phi. There is also a derivation for this VI cos phi in terms of the next circuit. So active power is given by P is equal to VI cos phi, where cos phi is the power factor and phi is the phase angle between voltage and current relation. Voltage and current phasor. आता आपल्याला माहिती झालंय फेजर डायग्राम आपल्याला माहिती, आपण व्होल्टेज आणि करंट मधली फेजर डायग्राम ऑलरेडी काढली. रेजिस्टिव्ह सर्किट, इंडक्टिव्ह सर्किट, कॅपॅसिटिव्ह सर्किट. तर त्या दोघांमधला जो अँगल आहे दॅट इज व्हॉट फेज डिफरन्स अँगल अँड दॅट इज फाय. अँड कॉस ऑफ फाय इज नथिंग बट द पॉवर फॅक्टर. बरोबर. मग आपण जर प्युअरली रेजिस्टिव्ह सर्किट साठी ही पॉवर कॅल्क्युलेट केली VI cos phi, तिथं अँगल किती होता? फाय 0. cos 0 is 1. So active power P is equal to VI in the resistive circuit, right? But in case of inductive circuit, that angle is 90 degree. So cos 90 is what? 0, and then active power will be 0 in inductive circuit. Similarly, in capacitive circuit, that phi's value is 90 degree, cos 90 is 0, then active power will be 0. So this is the active power. So there will be no useful work is doing in the pure inductor and pure capacitor. It only charging, discharging, charging, discharging. So this process is happening. Second is the reactive power or imaginary power. The portion of electricity that establishes and sustains the electric and magnetic field of alternating current in the equipment. So it is termed as the reactive power or the imaginary power. The portion of that electricity which will establish the electric and magnetic field, right? So this power is known as reactive or imaginary, or in other words we can say it is a loss, not doing some useful work. It is only producing the electric and magnetic field, right, and giving return back to the source. This is happening in case of the pure inductor and pure capacitor. It is denoted by Q and measured in terms of VAR, volt ampere reactive. The unit is what? VAR. The full form is volt ampere reactive. And in terms of the mathematical expression, it is given by Q is equal to VI sin phi. Opposite of cos, sin phi. In reactive power, there will be a sin phi. Now look at that. For resistive circuit, this cos phi is 1. Then P is equal to VI. But when you put phi's value is 0, then sin 0 is 0. Reactive power Q will be 0. There is no reactive power in purely resistive circuit. All the power which is active power. In case of inductive circuit, we have calculated active power is 0 because of cos of 90. It becomes 0. But what about sin 90? It is 1. So Q is equal to VI. So all the power which is there in pure inductive circuit, it is the reactive power, not the active power. Active power will be 0. Reactive power will be maximum. See, in capacitive circuit, same thing. Active power will be 0. Reactive power will be maximum. Next, which is the apparent.
इंडक्टिव्ह मध्ये -90 पाहिजे ना
काय
सर? फेज अँगल
इंडक्टिव्ह मध्ये
-90 असतं ना.
हा ठीक आहे ना, -90. पण पॉवर फॅक्टरला युनिट नाही, ते प्लसच राहील. 0 to 1 मध्ये त्याची व्हॅल्यू असते. फक्त लीडिंग लॅगिंग त्याच्या पुढे आपल्याला लिहायचं. इंडक्टिव्ह सर्किट असेल तर लॅगिंग, कॅपॅसिटिव्ह असेल तर लीडिंग, असं ब्रॅकेट मध्ये लिहायचं. न्यूमरिकलच्या वेळेस सांगतो मी. थर्ड इज द अपरंट पॉवर. It is simply defined as the product of RMS value of voltage and current. This is the total power we can say. This is vector addition of active and reactive power, denoted by capital S and measured in volt ampere, VA or volt ampere. If it is in high rating, then kilovolt ampere. Same thing for kilowatt and kilo VAR. K or M we have to multiply. If it is 10 raised to 3 or 10 raised to 6. And simply mathematically it is the product of voltage and current. S is equal to V into I, volt ampere. Now for understanding this power in any electrical system, so you can just refer this glass which is full of soda, or you may consider a coffee, you may consider a sugarcane juice, or you may consider a beer glass. So the portion of this liquid, which is what? The real power. Look at this is the portion of the glass where the coffee is present or the soda present. This is the real power. Look at that. And there will be a foam above this liquid. There will be a foam. Then this foam is termed as the reactive. Look at that. We are consuming it, but there is no use. This is the foam, so it will be a reactive power. And the combination of both these two, this will be the apparent power. See the useful work we are getting, we are consuming the coffee or soda, so this is the real thing. And what is the form there, which is the imaginary, which is not present any useful content, solid content, so it will be reactive. And the total of these two, that is the apparent. Hope you understood this. And the next one, which is the power factor. The factor which will be multiplied to the voltage and current, this is called the power factor. It is the cosine of the angle between voltage and current phasor. What did I say? The cosine of the angle between voltage and current. You know now what is the angle, what is phase angle, what is phase difference. So that phi, which represent the power factor angle. In terms of the equations, we can again represent this. It is a ratio of true power to the apparent power. Look at that. By this, true power to the apparent power, that is nothing but Vi cos pi by Vi, that is equal to cos pi. So that's why it is the ratio of true power to the apparent. In many ways we can calculate this power factor, even if it is from the phasor diagram also, that we know the angle phi, we can calculate by this ratio of true power to the apparent power. Right? Many ways we can calculate this. So ideally the power factor should be 1, unity, but practically it should be higher or near to 1. But practically it is not possible that it is always 1, even if it is a purely resistive or the combination of any of this RL RC circuit. So it may have less than 1. So practically it should be higher and near to 1. Why? Because the power factor, when we calculate it, which is what, P is equal to what the equation we have, basic equation of active power, Vi cos phi, right? This is our basic equation. So when we calculate this cos phi, that is equal to, this becomes at this side P divided by V into I, right? P divided by V into I. When the power factor is more, then the current will be less, right? Because of inversely proportional. And when the power factor is low, then current will be more, because voltage, it will be constant. We give 230 volt, 440 volt, it will be constant. There will be no change. The output power, that is also it will be constant. If load is consuming 100 watt, then it will consume the 100 watt at full load. Right? The variable parameter is what? The current. right? So whenever power factor's value is more, current will be less, and power factor value is less, current will be more, and there will be more reactive component present in the circuit.